All right, so to graph this first graph, first of all, by looking at my b value, I can tell you that this is going to be exponential growth. So this 2 right here, since it's a number greater than 1, this tells me that this graph will represent growth. Now when I do my table, my standard numbers are -2, -1, 0, 1, and 2. And all I'm really doing here is I'm going to take the number 2 and I'm going to raise it to each of these powers. So 2 to the -2 is the same as 1 over 2 squared, which is 1/4. 2 to the -1 is the same over 1 over 2 to the first, or 1/2. Remember, anything to the 0 power is 1. 2 to the first power is 2, and then 2 squared would be 4. So what I've just done is a table of values, and if you look over here, these 5 values right here, that's essentially the same thing I just did. The only difference is that these two numbers, instead of being written as fractions on the table on your calculator, they're written as decimals. So on the test, if this is a problem that you have to do that is not multiple choice, you're going to have to show the table, but you can use your calculator to kind of fill in the blanks. All right, so now I'm going to plot these points. So I'm going to go, I'm going left 2, and I'm going to go up 1/4. So that would be like right here. Then I'm going to go left 1, up 1/2, 0, 1, 1, 2, and 2, 4. And then I'm going to kind of connect the dots, and you can use your calculator to kind of guide your picture as well. This part of the graph that's over here, so like this part that I'm putting this little squiggly line underneath, that part is going to flatten out at 0. It's never going to cross through the x-axis, and you'll be able to see that by looking at the graph in the calculator as well. This next problem here is a decay problem, and I know that by looking at this b value of 2/3, since that is between 0 and 1, I know that this is going to, my graph is going to be a decay graph. So the first thing I want to do is my table of values. Remember that we're starting at -2 and we're going to +2. And then again, I have my table of values over here using my calculator. But if you're asked to provide a table on the test, you're going to have to actually write it out. It's not good enough to just know what it is from your calculator. So I have up here how you should type it into your calculator, into the y equals screen. And then if you go to the table, and remember you get to the table by pressing second graph. Okay, so 2/3 to the -2 power. Basically what's going to happen is you flip the fraction, so it's going to be 3/2 to the +2 power, or 9/4. And then again, that's the same as 2.25 if you look at the decimal. 2/3 to the -1 power would turn into just 3/2, or 1.5. And again, you can see it right here. Remember, anything to the 0 power is 1. 2/3 to the first power is 2/3, or 0.6, repeating. And then 2/3 squared would be 4/9, which is the same as 0.4, repeating. All right, so now I'm going to plot these points. So I'm going to go left 2, and then I'm going to go up 2 1/4. So about right here. And then left 1, up 1 1/2, 0, 1, 1 2/3, or 1.6. So right here. And then at 2, we're at 0.4. So this graph is going to look something like this. And again, it's going to flatten out at the x-axis. It's not going to cross through it. All right, the transformation rules for exponential functions are the same rules as before, which is kind of nice. So what I mean by the same rules is all the a, h, and k numbers do the same things. So your a value, which is right here, this is still going to represent a stretch, or let me say this first. It could be a reflection if it's negative. It could be a stretch, or it can be a shrink. Okay? And then your h value is still going to be a horizontal shift, so that means it's going to move your graph either left or right. And then finally, this k number is still going to give you a vertical shift, so it's going to move the graph up or down. So the letters do the same things, it's just that now the equation looks a little bit different. For these first examples, all we're doing is deciding a couple things. First, what the parent function is. whether it represents growth or decay, and then we're just listing out the transformations. So the parent function is always going to be whatever the base is to the x power. So for this problem right here, to identify the parent function, it would just be 3 to the x. And then by looking at that number, the base number, you can decide if it's growth or decay. Remember that if it's greater than 1, it's growth, and if it's between 0 and 1, so a fraction that's less than 1, it would be decay. So this graph would be growth since 3 is larger than 1. And then the next thing we need to talk about are transformations. So the only thing that's happening here is this plus 5. This is a k number, so this graph is being shifted up 5. Next, for number 2, we have an a value of 2, which is going to tell us a stretch or a shrink. But first, let's identify the parent function. So I'm looking for the base, which is 1/4. And then it's that number to the x power. So I don't need anything extra, just the base number to the x power. Since 1/4 is less than 1, it's between 0 and 1. This is a decay graph. And then as for my transformations, I like to go from left to right. So I have this 2 right here. That tells me that it's a stretch. Remember that numbers larger than 1 are a stretch. Numbers between 0 and 1 are a shrink. So this is a stretch of 2. And then this -1 here, that's the h number. That's telling me that this graph is going to shift right 1. All right, now number 3. My parent function, remember I'm looking for the number being raised to a power. So 4/3 is my base to the x, so that's my parent function. This represents growth. Even though it's a fraction, 4/3, if you typed it into your calculator, would give you 1.3 repeating. So it is a number bigger than 1. So it's growth. All right, transformations. I've got a negative. That gives me a reflection. I've got x plus 2. This is my h number. So this is telling me that the graph is being shifted left 2. And then this plus 7 is my k number, and that tells me the graph is getting shifted up 7. These examples are a little bit different. Now we're given a graph instead of an equation, and we're going to identify a few extra things. First of all, by looking at the graph, can you tell if it's growth or decay? So what I like to do is pretend that you are on a little roller coaster and you're on this graph. And if you follow this graph to the right, so you're always going to the right. If you're going up, it would be growth. If you're going down, it would be decay. So since if I was on this little roller coaster, if I rode this graph to the right, I would go up. This graph represents growth. The domain of every single exponential function will always be all real numbers, because if I went on this roller coaster, I could keep going all the way left, I could keep going all the way right. Eventually the graph would cover all of the possible x values. The range is a little bit different. If I rode on this roller coaster, I could go up. So if I followed this arrow, I could go all the way up forever and ever, but I would never get any lower than 0, because that's where this graph bottoms out. So for that reason, the range is going to be that y is greater than 0. It is not equal to 0. It will never actually equal 0. It just gets really, really, really close. The asymptote is kind of that invisible boundary line, and that would be this line right here. It's basically the line that tells you where the graph bottoms out. So this graph bottoms out at 0. So what I'm going to write here is y equals 0. So it's going to be a horizontal line, y equals 0, and it's always going to match. So these two numbers here, this one and this one, those two numbers are always going to match. So whatever y value you use for your range will also be the y value that you use for your asymptote. All right, now end behavior is a little bit different here. Here we go. So as x goes to infinity, so if I took this little roller coaster car and I went up towards infinity, my y value would also go to infinity. If I follow my graph to negative infinity, so now if I go to the left, my graph does not go to infinity or negative infinity. It flattens out at 0. So that's what my end behavior for my y value will be. So if I go to the right, I go up to infinity. If I go to the left, I flatten out at 0. All right, question number 2. So imagine yourself on a little roller coaster here. If you follow this graph to the left, you are going down. So that means that this is a decay graph. The domain, like I said, will always be all real numbers because these graphs will always continue going left and right forever and ever. The range is a different story. We have to look for that asymptote number, or the number where the graph flattens out. So I'm going to go ahead and draw in the asymptote. So it looks like right here is where this graph kind of flattens out, and that would be at the y value of -3. So my range is that y has to be greater than -3, and then my asymptote is going to be y equals -3, because remember, those two things will always use the same number. Now for my end behavior, as I go to the right towards infinity, my graph flattens out and goes towards -3. As my graph goes to the left, or towards negative infinity, now my graph is going up towards positive infinity. Last question like this one. So remember, imagine that you're on a little roller coaster. If you were on this roller coaster and you went to the right, you would be going up. So this graph represents growth. The domain will be all real numbers, just like the rest of them. The range is going to be everything greater than +1. And the reason is because if you look right here, this is where the graph flattens out right at +1. So that's also your asymptote, is y equals 1. The end behavior, if I go towards positive infinity, so to the right, this graph goes up towards infinity. And if I go towards negative infinity, or to the left, the graph levels out or bottoms out at +1. The parent function of this graph here is 2 to the x. The transformations are that it is being shifted to the left 5. In order to write our table out by hand, which you'll be required to do if this is not a multiple choice question on a test, the way you want to figure out your middle number on the table is by taking the h value of your function. So I want to write out the formula really quick, kind of our standard form. So a times b to the x minus h plus k. So whatever your h number is, that's the number that you want in the middle of your table, and then you want 2 points above, 2 points below, so 5 points total. So in our problem here, our h number is -5. So I want -5 in the middle, and that means I want -6, -7, -4, -3. Now from this point, we're going to go straight down here to our table, and we're going to take those points off the table. So -7 is 0.25, -6, 0.5, -5, 1, -4, 2, and -3, 4. And now I'm going to plot these points. So if I go left 7, 1, 2, 3, 4, 5, 6, 7, and then up 0.25, so about right here, and then 0.5, 1, 2, and 4. So this is what my graph looks like here. The parent function of this graph would be 1/3 to the x. The transformations occurring to this graph, there's only one. This graph is being shifted down 2. To make my table, remember that our h value is going to determine the middle of our table. In this problem, there is no h value. That means the middle of our table will be at 0. And then I want 2 below, 2 above. So it's kind of our standard numbers that we always use. So on the calculator, which you'll use to get your y values, I kind of put a box around the ones we're going to use. So this would be 7, 1, -1, -1.67, and -1.89. All right, so I'm going left 2, up 7, left 1, up 1, at 0, -1, 1, -1.67, and then 2, -1.89. So my graph is a decay graph, which you could have seen by looking at the equation. The 1/3 tells you that it's a decay graph. And again, you could check against your calculator's graph to make sure that your graph looks like the calculator's graph. The parent function of this graph would be 3 to the x. There are 2 transformations. There's a shrink of 1/2. And this graph is also being shifted up 1. For our table of values, we want to start in the middle at 0 because that would be your h value. So this is going to be using our standard numbers from -2 to +2. So here it is on the table from your calculator. So I'm just going to copy down these numbers. 1.1667, 1.5, 2.5, 5.5. And now we just have to graph these points. So I'm going to go left 2, and then up 1, barely over 1. And then left 1 and a little bit more over 1, but not much. 0, 1.5, 1, 2.5, and then 2, 5.5. And then I'll connect the dots. And again, you can use your calculator's graph to kind of make sure your graph looks the way it should.